There's a lot of notes today and a lot of vocabulary. So let's get started with it. The first thing is a relation. Relation is a mapping or pairing of input values with output values. What that means is that we're going to pair up x values and y values. That's the most common one that we use. Yes, there's other types, but the one that you can associate to the best is that an x value is an input, and when we put in an x value, we get a y value out. The domain is the set of all the input values. Well, the input values are more commonly known as the x values. Therefore, our primary purpose of a domain are to come up with all the x values of our relation or our function. Range is the set of output values. Output values represent our y values. So a function is a relation. It is a relation that has exactly one output for every input. So every x can only give me a y. In kind of easier terms, you can only use an x value once. And that's going to be kind of the key one that we tend to remember most. We don't necessarily remember this. A relation has exactly one output for every input. But what we do remember is that the x is unique. That x value, 2, can only give me one solution of a y. So the x values cannot be repeated. X values cannot be duplicated or repeated or used more than once, or whatever one you want to put in there that says you can only use them once. Okay. Our relations are represented in many ways. You need to be familiar with all of these ways. The first one is called a mapping. A mapping has this kind of circular ovals, and they pair up or match up the left circle to the right circle. We also call the left circle the domains, ranges, x's, y's. However you want to think about it. The one that comes first is the one we read first. So -2 matches up to -1. -1 matches up to 0. 0 matches up to 1. And so on. That's called a mapping. It's in circles, and they have lines connecting. The next one is a table. We should be familiar with this, an XY table. If the x value is -2, the y value is -1, and so on. Then we have graphs. Again, -2, -1, -1, 0, 0, 1. The numbers are being used the same throughout. So that would be the graphing of the points. Then we have an equation. If I put in my x value, -2, if I put in -2, I would get -1. If I put in -1, -1 plus 1, I'd get 0. So this is the equational representation of these different formats. We have ordered pairs. We can get our ordered pairs from the mapping. We can get them from the table. We can get them from our graph. When we plug things in to the equation, we can get our ordered pairs. And vice versa. The ordered pairs can give me the picture. The ordered pairs can give me the mapping. We need to be able to go in both directions of the information given. And the last way we use is called words. For example, in this case, we would say the x value 3 is paired to the y value 4. The x value 3 is paired to the y value 4. All right, we call this, I call it anyways, the NAW process. All right, the NAW process is something you need to be very, very comfortable with. The NAW process says you can understand a graph. That's this. You can understand numerical. So let's see, graph. You can understand numerical representations. This is a number representation. This is a number representation. This is a number representation. You need to be able to understand the number, the numerical representation of your information. Then we have algebraic. Now, algebraic are equations. So that's this. So we have graphically, numerically, algebraically, and W stands for words. And we need to be able to interchange these processes frequently and with comfort and with ease. Be able to go, this equation gives me this graph, which gives me these words. These words give me these numbers, which gives me this equation. This graph gives me this equation, which gives me these numbers. Right? They need to be able to be interchanged, and that is something that will be highly expected of you as we start moving through these and we move to different types of pictures. Right now we're talking about lines, and that's what this chapter is going to be about. But we're going to start looking at different pictures, and all those pictures are going to give us the same graphic, numeric, algebraic, and words information. And you've got to be able to come up with the other pieces based on whichever one is provided for you. All right, so that's the NAW process, and those are our different relations in being able to represent them in many ways. Okay, so let's talk about, is a relation a function? Now, on the previous notes, we just said a function is a relation. So now the question is a relation a function? Do these interchange with each other? Do they go back and forth? it is a function, certain things must be true. The first thing that must be true is that every x value has only one y value. Okay? What that means is exactly what we just said before. The x values cannot be duplicated. Positive 2 can only give one solution. It cannot give more than one y value. The next thing that we could do is graphically we could look at it. We could run what's called a vertical line test. And you'll be able to abbreviate that because you'll be asked, is it a function and why? And you can use vertical line test, VLT, as a shorthand. But the vertical line says that if you ran a vertical line over a picture, it can only hit the picture or the graph or any one point at any given time. So there's two ways that we can look at this. If we have a list, we can look, are all the x values only once? But if we have a picture, well, then we look at the picture and we say, if I run a vertical line, and a vertical line is up and down, if I run a vertical line up and down, do I only hit it one time? So let's look at some examples here. The first example is a table. X is 0, 1, 3 with the y values -1, 2, -1. We only care about x values. So when I look at my x values of 0, 1, and 3, they only happen once. That is all that matters. I don't care about the y's. The x's only happen once. So is this a function? Yes, it's a function. And you're going to see me use FN as an abbreviation of function. Okay, when I go my mapping, 1 goes to A, 0 goes to A, 0 goes to B, -1 goes to B. So again, all I care about are my x values. The x value 1 goes to A, so that's only used one time. But 0 goes to A and 0 goes to B. If it's used twice, it's not a function. Then the third one we have here is a picture. A picture means we're going to run a vertical line. And if I run a vertical line, I should only hit my graph one time. So here's a vertical line, and I only hit one time. I only hit one time. I only hit one time. But when I get up to here, when I run this vertical line here, now you can't see too well because of the thickness of my pencil. But if you run a vertical line here, I hit maybe one time, 2 times, 3 times, and that can't happen. So not a function. And if you're asked why, you would say it fails the vertical line test. If you're asked why, you would say because the 0 is duplicated. If you're asked why, it's because no x is duplicated. And you will be asked why. So you need to make sure you understand the reasoning as to why something is a function or is not a function. Okay. Many functions are represented by an equation, which means the solutions to these equations are in ordered pair format. Parenthesis, x, comma, y, parenthesis. Solutions are in coordinate pair format. X, we've talked about a little bit, is the input values. It's also known as the independent variable and domain. So the Y's are our outputs, which makes it the dependent and the range. When we graph all of these points, the collection of all the solutions, that's when we get the graph of the equation. The graph of the equation is the collection of all the solution points. When we start putting all of these points together, we're going to start creating lines. And that's what we have next. We are going to be creating lines, which is linear. Linear means the graph is a line. The equation of a line is y equals mx plus b. This should be something you are already familiar with, is this format of the equation. And every single time we have a line, the highest power of the equation will be 1. Now we're used to y equals mx plus b, and that is definitely our algebra notation. So to advance it into our algebra 3-4, we're going to start using what's called function notation. That means we're replacing the y with f of x. That is all that it means. It still creates a line. It still has the highest power of 1. It's just instead of saying y equals, we now say f of x equals. And that is how we read it as well. F of x. F of x has the equivalency of y. So whenever you saw y before, you could now write f of x. And vice versa. Now that you see f of x, you could write y. F of x has the value of y, y has the value of f of x. What we need to get used to is now, what does this new notation represent? F of x means for a given value of x, what is y? Or the other way to kind of say it is, at a given x point, you get this y out point. For some x value, you're going to get a y value. Keeping in mind, your x's are your domains, your y's are your ranges. X's are your independent, y's are your dependents. So for every given value of x, so that means anytime I put an x in, I'm going to get a y value. And that's what this is going to represent. Other letters can be used, especially in physics and when we start getting into word problems. They might use g of x, h of t, v of d. Generally, they're representing word problems. Like h of t would be the height related to time. where time is the x value and height is your y value. V of d, so that might be velocity of distance, where distance is representing your x values and velocity is representing your y values. Again, those you usually use other letters once you start moving into word problems. But to have f of x or g of x, those are pretty typical, normal equations. So first of all, before we can move into the word problems and start applying things, we need to make sure we know how to evaluate a function. Now, clear back in section 1.1, we hopefully got out of that to evaluate means to substitute. Just a different word, but we're going to be evaluating a function, which means we're substituting into a function. So here I have a function, f of x equals 3x plus 1. And I want you to find f of 4. So the way that we are reading this is saying, here's my y equals 3x plus 1. My function at x is this equation. So I want to find the function, which again means y, when x is 4. Find the y value when x is 4. So the math process, substitute, because that's what we just said evaluating meant for us. F of x, and we want f of 4. That means x is 4. These are the same. X is 4. Now if I just told you x is 4, you could put that in and find it. But you need to recognize this new writing, this new format. F of 4 means x is 4, which means we're finding a y value. Given an x, you find a y. So substitute in f of 4 means we put 4 into the x location. And you should be able to go 12 plus 1 and get 13. So what does this mean? Everyone can substitute. Everyone can simplify and get the 13. But what does it mean? And that's the difference between our algebra and our 3-4, is that now we have to start putting meaning behind what we do. What this means is that at the x point of 4, because that's what this is, x is 4. At the x point of 4, the y point is 3, because f of x, f of 4, means y. It's also a coordinate point for 13. The x value is 4, the y value is 13. It's also a point on my graph if I wanted to graph it. So for the class in the class assignment, we're going to be looking at doing these kind of substitutions and really understanding that yes, you can substitute, yes, you can do the robotics of it, but we need to understand the meaning behind it. That when you're putting in a number into an equation, you are getting a y value. That y value connected with the x value that was given creates a point. A point is a solution. We got to start connecting dots. We got to start moving forward with our understanding of our solutions.